All right. Hello there. Hello. All right. This is pretty much one of the last sessions of the conference, so we thought we're going to keep it fun, as we call it, as drink from the fire hose. So it's a lot of content in here. 50 features of Java EE 7 in 50 minutes. And I realize I've already lost like 20 seconds doing the introduction here. My name is Arun Gupta. I work for Red Hat. I'm the Director for the Developer Advocacy. That means responsible for developer outreach efforts for everything that is JBoss Middleware over there. Okay. Now in this talk, okay, it's asking me for the Wi-Fi password. I don't need the Wi-Fi password right now. The slides are going to be the format wherein you see the feature number on the top left, then you see the specification, and then the actual feature description. Okay, this is what I call as the Java EE pancake diagram. At the bottom, what you see is a platform. Then there are some specifications in the middle. They can be used on top of each other. Then there are certain specifications on the left which are across the platform, and then there are certain specifications on the right which you can use depending upon which layer you are in. Okay. So let's go from left to right and talk about these specifications. Each of the slide is a brand new feature in Java EE 7. These features are a brand new addition. Okay, so let's talk about CDI. CDI was such a fundamental change in Java EE 6, but we still say, okay, you need to explicitly enable it. In Java EE 7, that changed. CDI is default enabled for you. So if you are using a Java EE 7 application and you have a POJO with a CDI scoped annotation on it, that bean is by default enabled for injection. No need for beans.xml over there. However, in addition, if you are using beans.xml, then you have a new attribute called as bean discovery mode, where you can say all. That means no matter whether there is CDI scope or not, make that bean available for injection, or annotated, which is the default, or one switch where you can say turn off. No beans are available for injection. This depends upon where your beans.xml is bundled in the archive, and that is the scope of this beans.xml. A new annotation added to CDI 1.1 called as @vetoed. So you are working in your project and you don't want a particular bean to be injected, so you put the annotation @vetoed. That particular bean is not available for injection anymore. Now, if you have multiple packages in your archive and you want a particular package not to be injected, then you can put in the package info, you can put the annotation @vetoed, in which case the entire package is removed or not available for injection. All right, so quick features. This was JSR 346. Now bean validation 1.1 is JSR 349. This specification was added in Java EE 6, and the main thought process over there was to be able to specify validation constraints on your bean. And then those constraints are honored by JPA and JSF layer. Well, that was in Java EE 6. In Java EE 7, it's a lot more prevalent. So you can take any POJO. In the POJO, you can start putting annotations, the same constraints. In the method, for example, so here I'm saying, when you invoke this POJO or the constructor, I want to make sure the algorithm is not null. Okay? In this case, not only the algorithm is not null, or the credit card is not null in this case, when you are returning a value, it better be true. If it is false, think about throwing a constraint violation exception. This is what we call as programming by contract. That means if your parameters, which are inbound values, or return values, which is outbound value, are not meeting the contract, think of getting an exception back. Or this is a runtime exception, constraint violation exception. This is JSR 349. All right, Interceptors 1.2. JSR 318. As part of Java EE 6, we took Interceptors 1.1 out of EJBs. They were only available in EJBs earlier, but in Java EE 6, we took Interceptors out. Now they're a lot more widely applicable. What we added in Interceptors 1.2 was @around construct annotation. Earlier you could say, oh, call this method around the methods. Like when in a POJO, a method is being called, call this method before or after the method. Now you can do the same with constructors as well, literally by putting the annotation called as @around construct in your interceptor. Something else we added to interceptors was priority. So let's say you have a bunch of interceptors and you want to start prioritizing them in a particular order. Now you have predefined values, sort of platform before, library before. The ones that are in higher priority order are called first. The ones that are actually the ones that are lower priority order, or the number 0 is called first, and the number 4000 is called later. So you can have multiple interceptors in your archive, and then start prioritizing them, and then they're called in that specific order. You can even give, for example, relative priority. So for example, in your application server, let's say somebody has already bundled an interceptor, and you want your interceptor to be called before that. Hopefully they have user right priority. You can say plus or minus 10 and accordingly get it called before or after. Concurrency. Now Java, okay, it's going to keep asking me the myriad guest number again. Java EE is a managed environment. As a managed environment, you cannot spin up user threads over there, because managed and user managed are two different environments over here. So JSR 236 adds the support for managed threads. Easily create managed threads as part of Java EE application. Now, we are using the standard JDK design principles. So if you're familiar with the JDK managed or executor or JSR 166Y, that's where all the concurrency utilities are added. The idea is to kind of leverage that and provide a managed version of those objects in Java EE 7. So here, for example, I can say instead of executor service, which is already there in JDK 6, I can say managed executor service. So I could just say add resource, and now is injecting a managed executor service. Well, that's one way. The other way is I can do a JNDI resolution. So here I'm specifying the JNDI name, and from the initial context I can do a lookup and I get my managed executor service. Now notice here I'm using a default managed executor service. That's a new default object that is added to the Java EE 7 platform. If you, in this case, for example, when I'm injecting the managed executor service, I'm not even specifying what JNDI name is going to be. So it automatically defaults to the managed the default resource. Third way by which you can inject your managed executor is by specifying your application specific managed executor. So you can have multiple managed executor in your deployment descriptor and specify the JNDI name, and the platform automatically instantiates it for you and makes it available for injection. So you have managed executor, you also have managed schedule executor. Very similar to managed executor, but basically providing a managed version of schedule executor. The main difference over here is you can submit your delayed or periodic tasks. Like submit this task after first 2 seconds delay, and then every 3 seconds after that. Just like your managed executor, you can inject it using add resource over here. Or you can do the JNDI lookup, or you can also specify in the web deployment descriptor as well. So all three ways are available for managed schedule executor. The APIs are pretty simple, as I was saying. So here I'm saying schedule this task after 5 seconds, okay? Or schedule at a fixed rate. So you're saying schedule this task with the initial delay of 2 seconds and 3 seconds after that. And there are semantics that are well defined in terms of what if the previous task has not finished, what if there is a deadlock and things like that. We are not really reinventing any new thread over here or new design principles. All these design principles, APIs, Java docs, they exist in JDK, just providing a managed version in that so that container can give you a thread where you can run all of your application logic. Now we have thread factory in JDK, this time we have a managed thread factory. So same again, we are using the default managed thread factory. Specifying the default managed thread factory and not specifying it is one and the same thing. It automatically faults back to that. Here I'm using the JNDI lookup, here I'm using the add resource. Now, once I have the factory, from the factory I create a new thread, and then I can run my task in there. My task is basically what is implementing runnable. Now the big difference over here is, why would you do a container managed thread? In a container managed thread, the biggest difference is you have your class loading context, security context, JNDI context. All of those contexts are available, which are not available otherwise. If you're running a user managed threads, none of that context is available. The only context that is not available is the transaction context, because coordinating transactions across multiple threads is not a simple problem. Now we talked about 3 managed objects. We also have something called as dynamic proxy. So you can add contextual information for any Java EE object in this case. So as I said, class loading, GIND and security information is available to you. But how do we use dynamic proxy? Well, same way. We inject context service. Then from the service, we create a contextual proxy, and I can give it a pointer to a runnable class. So it will automatically provide all the context information to whatever that POJO object is, and then you can submit it to an executor. All right, jump on to JSR 338, which is Java Persistence API. So far, JPA has the capability by which you can say, take a database, from that database, generate a JPA entity. And yes, we can do that. Now, in JPA 2.1, you can say, take a POJO entity, from that POJO entity, create my database schema. So this is done by using JavaX persistence schema generation properties. Okay. I'll take a second break, and actually I will quickly disable this puppy here. And it's not showing me here because the resolution is horrible. All right. I think we'll live with that. Okay, I wasted 30 more seconds here as well. So now we have JavaX persistence schema generation properties. So what I'm doing here is I'm saying drop and create. So I'm going to drop the tables and create them all over again. And in this case, I'm saying the script's create target is create.sql. So essentially in my war file, I have create.sql script bundle. It's going to take that script and it's going to generate the database. I could also specify the value over here as scripts.createTarget as metadata, in which case it's going to look at my existing JP entities and generate the database tables from that. Or I can say take my JP entities and generate scripts from that. Those scripts can then be given to your DBA, who can then fine tune it and then give it back to you for deployment and for generation of database tables at deployment. Very important, specifically if you're going in a cloud environment where you can bundle the scripts and say, you know what, generate my database tables on the fly. Not just DDL, but DML. You can even manipulate your database as your tables are created, populate them as well. Now, when you're creating your tables, you want to create indexes. So we got some new annotation in there. So in this case, well, by default, there is an index on the primary key always. But if you want indexes on other tables other columns as well, so you can start specifying in the table annotation indexes. So you can say generate an index and provide a column list over here. JPA has a persistence context. So every time and any time you write to the persistence context, it is part of a transaction. And whenever the transaction commits, it writes the state of the persistence context to the underlying data store, which could be RDBMS or some JCA connector. Now, with JPA 2.1, we're introducing called as unsynchronized persistence context. That means the entity manager, which is having the persistence context, is not part of a transaction. So you can read from the persistence context, but since it's not part of a transaction, nothing is reflected into the data store. Now my entity manager has to explicitly join a transaction, and that's when the transaction is committed, it writes everything to the data store. So that's sort of an important differentiation to remember. Unsynchronized persistence context. Now in JPA, we also have access to named queries, which are basically my JPQL, or Java Persistence Query Language, in which case these query languages are compiled, and what I'm doing is I'm writing those query languages at one place, kind of following my dry principle, or don't repeat yourself. I write those queries at one place, and I use a symbolic name throughout my code. So my queries stay at one place. Now, leveraging that concept, you have stored procedures defined in a database. You can start leveraging them as part of your JPA code. So here in this case, I can say my named stored procedure query. This is the actual stored procedure, SP archive books, which is defined in the database, and this is my symbolic name. Now, stored procedures have in, out, and in-out parameters. So all of those can be defined over here, so you can do the full interaction with stored procedures. All right, now getting onto JSR 907, which is JTA 1.2. JTA is Java Transaction API, which defines how transactions are done, or at least the API on how the transactions can be injected. JTA allows before this, JTA allowed only user-managed transactions. So you can inject a user transaction object, and you can say transaction big commit or begin or rollback. If you wanted to do container-managed transaction, the only way that was possible was in EJBs. People don't like EJBs generally, even though we have improved them significantly. But now with transactional annotation that is added new to JTA 1.2, you can take any POJO, you can put this add transactional annotation on the POJO, and the container automatically manages the transaction for you. Well, it is done using CDI interceptor binding, so that's a very powerful concept. Not just a class, it can even specify on a method of a class as well. So let's say you have a POJO with 5 methods in there, you want to make only one method transactional. On that method, you put the add transactional annotation, and only that method, container will automatically start and commit/rollback the transaction based upon the conditions defined in the specification. In this case, I'm explicitly specifying that roll back on these 2 exceptions and don't roll back on a warning. Just like, oh dear. Now, we have also defined a new CDI scope called as transaction scope. This basically ties the life cycle of a bean to a transaction. So for example, here in my servlet, I'm trying to inject 2 books here. So book bean B1, book bean B2. Now book bean is a transaction scope bean. Now within a process request, I'm starting a transaction, and then I'm trying to get the reference to both the beans. So B1.getReference and B2.getReference. Now the way CDI works, because I'm injecting the bean over here, it has a proxy. And then the proxy is backed by an instance at the runtime. It figures out what is the scope of the bean, and if the bean exists in that scope, it automatically backs it up to the proxy. So here in this case, when I try to inject the bean, there are 2 separate proxies, but it says, oh, you are in a transaction. Let me see if there is, when you do the first invocation, it says, oh, let me see if there is a transaction scope bean. If it is not, it creates a new one, puts it into the bucket, and gives you the new transaction scope bean. But for the second one, because the bean already exists in the transaction scope, it gives the same bean. So B1.getReference and B2.getReference in that sense are going to be the exactly same beans. EJB. Now EJB 3.2, significant changes were made in Java EE 6. With EJB 3.2, it's a sort of a minor release. So one of the big things over there we did was added the capability to disable passivation of stateful beans. You can just add this passivation capable equals false. This can give you certain performance improvements if you don't want your stateful beans to be passivated. Another minor change to EJB 3.2 is now that asynchronous beans, in EJB you can do asynchronous tasks both the ways, like fire and forget, or get back a future object and then query it, poll it for getting a response. Both of those are available in web profile, and the non-persistent timer, which are obtained by persistent equals false. Both of that are available in the web profile now. All right, JMS. JMS was one API which went through significant changes. Now JMS 1.1 was done 2003, so more than 10 years ago. So it was long overdue for a change. So, simple change, this is a new simplified API. We have @inject JMS context. This is really my entry point to the simplified API of JMS. And I want to create a producer, so all I say is create producer, send the message, this is my destination, and this is the payload. That's it. I want to receive a message, same thing, create consumer, specify the destination, and receive the body. And you specify the type of the body, in this case string.class. It's a little bit more fluent API, so you can use the builder pattern, specify a little bit more semantics. It's a convention over configuration. If you don't specify, then there are default conventions it uses. Now, just this line took about 25 lines of code in JMS 1.1 because the API was bulky, because we were using lots of checked exceptions, because of try, catch, finally throwing exceptions all over the place. But finally we learned the lesson, and the API is simple now. Now in this case, what we showed you is container managed JMS context. You can also do an application managed JMS context. And if you are doing that, then it's recommended to use try with resources block, because this will automatically close as soon as it goes out of the scope. Okay. Yeah. Now, one of the typical issues with JMS is when you give your war file or ER file, which actually has a JMS queue, you will typically give a deployment script. Oh, create this JMS destination and queue or topic. Now, this annotation will simplify that. So, for example, here in my EJB, I could specify annotation called as JMS connection factory definition. And this is a topic connection factory. So, at the time of deployment, my Java E7 container will automatically scan for these annotations and connect or create the connection factories for me. Similarly, not just connection factory, I can even create the destination as well, be it topic, be it queue. So both of those can be very easily created as part of the deployment itself. So effective idea, your deployment script goes away, at least from the JMS perspective. Servlet. Now in Servlet 3.1, what we do is if you have a do-get method, and if you're reading something from the client, typically is non-blocking, in the sense that in your do-get method, you are reading, you say input.read till it's -1. That -1 could be for many reasons. Either the client forgot to close the stream, or is still sending some data, and the data is coming sporadically only. But effectively, your thread on the server side is blocked. So Servlet 3.1 added non-blocking I/O. Well, how it's done is very standard design pattern over here. Basically, you set the read listener. This is a new interface, or you set the write listener. In terms of read listener, we got methods like we are sorry for the inconvenience. Recover my work and restart my Microsoft PowerPoint. Okay, well, first of all, let's disable our Wi-Fi. Okay, don't send the information. What? Really? Oh gosh. Well, I know why Antonio hates Microsoft PowerPoint. All right, so we're back on the read listener and write listener interfaces. On those two interfaces, we have added methods like on data available, on all data read, and on write possible. And the way they work is, in your async servlet, you will set up the read listener, and effectively you will pass it the input stream. So here you're passing the input stream. So whenever data is available, so my read listener has this method called as on data available. That method would be invoked. So it's a very simple suspend and resume design pattern, but the idea is if data is available, then the method is called. If it's not, it goes back to your servlet effectively. So the thread is parked for you in that sense. Now the way WebSockets work, and we haven't talked about WebSockets yet, but WebSockets work on the concept of HTTP upgrade. It takes an existing HTTP connection and uses a standard HTTP upgrade mechanism to upgrade to a non-HTTP traffic, which is basically WebSocket. Now the support for that really comes from Servlet 3.1. WebSocket is the first realization of that. Hopefully more protocols would be used, but this is the API that is added in Servlet 3.1. Effectively, you get the underlying input and output stream, and you can upgrade to whatever protocol you want to. But then you're effectively on your own, because there is nothing HTTP about it after that. Let's take a look at my Servlet 3.1 deployment descriptor. So here, I have a deployment descriptor, which has a method which is calling HTTP GET, and there is some authorization constraint on it. Now, if you have nothing, then all the methods are protected. That means none of them can be invoked. But if you have one, then that means all other methods are unprotected. What that means is, because you have specified something for get, that means you want get to be protected, but post, put, delete can be very easily invoked without any security constraint. So that's a security hazard. Now here, what we've done is we've added a new element called as deny uncovered HTTP methods. So in my previous case, if get is covered, all other methods are uncovered. So now what I'm saying is, by default, just deny any uncovered methods to be accessible. Just that simple element does it. There is no corresponding annotation for that. WebSocket, okay. Now, WebSocket, that is, in my opinion, one of the biggest additions to the Java EE 7 platform. And my single line definition for WebSocket is, it enables full duplex bidirectional communication over a single TCP. So let's spend about 30 seconds on that. It's bidirectional because unlike HTTP, which is always client to server and then server responding back, in WebSocket, the client can talk to server and server can talk to client independent of each other. So that's bidirectional. It's full duplex because they can both talk to each other independent of each other, unless in half duplex where either client can talk to server or server can talk to client. They can talk to each other independent. And the biggest advantage over here is over a single TCP connection. So once you have the basic HTTP connection established, you say, now I want to do a WebSocket connection, and so it's going to upgrade that to a WebSocket connection. But then once it's upgraded to a WebSocket connection, the underlying TCP connection stays open. All the communication between client and server, which effectively become peers, is over that single TCP connection, right? A lot of details about WebSocket, but how do we do WebSocket endpoint in Java EE 7? Well, by just one single annotation. Here I'm building my very canonical chat server. So I say chat server, server endpoint, and the URI. That's it. So that means this is the URI where my WebSocket endpoint is listening. Now, a WebSocket endpoint can receive text data or a binary data. If I'm receiving text data, then I put string as a method parameter over here, and session encapsulates the conversation between the client and the server. Now, I just want to broadcast the message. Now, typical WebSocket programming model is you have server at the center and all the clients are at the edge of a wheel. So it's a hub and spoke programming model. So the client talks to the server and then server broadcasts to all the clients. And that's what I'm doing here. So for example, here I'm saying, give me all the open sessions on this server, and then on each session, I'm just sending the object that is being received over here. So the text object. So this is a very classic chat server. But just this line by itself is going to serve as a chat server for you. Just this class packaged into a WAR file, just a single class, no deployment descriptor, is going to be a fully functional chat server. WebSocket also has certain lifecycle callbacks. So you can say, tell me when the client connects to my server, and give me that more information about the client. Tell me when a client closes the connection with my server. Give me what the close reason is, or if a client throws an error, give me a throwable instance so that I can figure out more details about that error. So the standard lifecycle callbacks, they mimic very closely, they actually mimic exactly like the ones in JavaScript API for WebSocket. Now we can do server endpoint, we can also do a client endpoint as well. In the case of a client endpoint, I just say public class my client, and I put the add client endpoint annotation. The important difference here, first of all. So here, this is in JavaX WebSocket server package. Here is in the JavaX WebSocket package. So there's a conscious decision being made, okay, keep the client and the server API separate. If there's any server-specific API, keep it in a server package. Well, that's one. Second is the client endpoint. Remember, we talked about client is at the edge of the wheel. Client is not listening from other peers. So client does not have a URI. So here, you don't specify the URI. As a matter of fact, when you actually want to connect a client to a server endpoint, then you need to say, container, give me the WebSocket, or the provider, give me the WebSocket container, and then connect to a server. You specify the instance of the class. Actually, you don't specify the instance. You specify which class to connect with, and then you specify the WebSocket URI, which is starting with ws://. That's the URI scheme to be used for a WebSocket endpoint. We saw the annotated endpoints. We can also do the programmatic endpoints. And in order to do the programmatic endpoints, you need to say extends endpoint. Well, first of all, why would I do that? It provides you a little bit more configuration and control over how you configure your endpoint. So for example, in this case, I'm just overriding on open method, and it gives me an endpoint config. In endpoint config, I can configure a lot of different kinds of data. So for example, how my server instances are being created, how my handshake is being how my handshake is being done, what underlying HTTP headers are looking like. So all that detailed information is available to you, and you can manipulate that. Now, a little bit more work needs to be done. You need to explicitly start adding message handlers. So in this case, I'm adding a text message handler, starting with string. I can receive the entire message, or there is another variation by which it says you can receive partial message as well. So depending upon your use case, it does give you that control. Now, this is a programmatic endpoint, so what's missing over here is my URI. So in case of URI, I need to implement an interface called a server application config, and that's where I specify what my URI is going to look like. A little bit more about the programmatic endpoints. Once I extend the configurator, in the configurator, I have my endpoint instance, modify handshake. I can overload those methods and then say, okay, this is what I want to do in my configuration options. Now, as I said, in a WebSocket endpoint, you receive text data or binary data. You may not want to deal with the text and binary data all the time. You may want to deal with your POJOs or business domain objects instead. Now, once you receive this text or binary data, you can, of course, convert them in your business method. Not a good design pattern. So in order to support that, WebSocket provides you the concept of encoders and decoders. You can specify your encoders and decoders as part of the annotation. So here I'm saying, decoders is my decoder.class, encoder is this. And then instead of receiving a string, you're receiving a chat message. How is this chat message created? Well, my decoder says, I'm going to take a string, which is on the wire format. I'm going to take a string and convert that to chat message. And you can use whatever technology, whatever API you care about in this case. There could be multiple decoders, and in which case, one of the will decode methods will return true. The idea is to kind of peek into the message a little bit and return back, oh, this makes sense. I can decode this message, and I will return a chat message instead. Similarly, you have encoder, because on the wire is still string, so it takes your POJO and converts it to string. EL, expression language 3.0, I think this was JSR 343. This has always been part of Java EE platform, but kind of bundled with JSP, was leveraged in Java server faces. So in your Java server faces pages, if you are saying hash within the curly parentheses, if you're putting something in there, that's your expression language. But now, with Java EE 7, EL is a separate specification. And the idea is, you have something EL processor with you. You can use that EL processor, run it in a Java SE environment, or any of your Java application, or Java EE application. So you want some expression language processing capability as part of your Java EE application. You can instantiate, for example, EL processor, and then you can say what bean is being, like if a bean value is specified, you can start specifying what does it map to. So you can get a corresponding bean instance, call the get set methods, invoke the operations. So anything that you can do in JSF can be easily done in your custom Java EE application with this. Okay, talk about JSF. JSF 2.2, one of the big ticket items over there is the addition of faces flow. Now in a JSF or a web application, let's say you are going through a flow. So for example, a shopping cart. So if you're doing a shopping cart, then you have the first page where you selected the items, then you add the address, then you add the credit card details, something more. So there is currently no way in JSF which says, oh, this is how I can package all of that flow into one directory. You can adopt your own custom convention, which is okay, but that doesn't scale because that is not across your projects. So here, what we are saying is, in a web app directory, which is a Maven project, so in a web app directory, you can create a directory called as flow1. This is your custom name. But as long as there is a flow1.xhtml, so directory and the file name are exactly same, that is the entry point to your flow. Now in flow1, potentially you have buttons. You can say click on this, do that. You can click on the buttons and that will define the flow, and eventually you will exit out of the flow. So that defines what your flow is going to look like. And you can also define, if you don't want to keep that naming convention, then you can say flow2-flow.xml. So you can declaratively define how your flow is going to look like. So where there is an entry point and exit point, the biggest advantage is you can package this flow in a jar file and you can share it with others. There is a flow scoped annotation here as well. So you can say, I want to store all my flow scope data. Again, the instance of this bean is tied to a flow. So in a JSF page, if you try to get an instance of the bean, if you are within a flow, it will give you the instance. Otherwise, it will not give you the instance. We talked about declarative definition of flow. You can also do programmatic declaration of flow. So like at the runtime, I'll figure out what my flow is going to look like. So you can start doing that programmatically. Just need to use CDI produces flow definition annotation. There are certain other EAL expressions available to you. So you can say flow scope or whether I'm in a flow or not. So convenience ones. Now JSF also introduced the concept of resource library contract. With JSF2, we introduce XHTML and CSS and facelets as the templating language. So you can say my view is purely in XHTML and CSS. My M and C of the MVC, model and controller, goes back in my JPA and EJBs or CDI beans. That only took us to a level where we could say, okay, I can do now true MVC. But what's missing is, how do I do pluggable templates? So now you can say is, in my var file, I'm going to bundle a contracts library, whatever the library name is. In the library, this is a predefined directory structure. You can say meta-inf contracts. In that directory, you can have multiple directories. Each directory could have a corresponding template. So you can say CSS, you need to have this marker file, and you can have your templates, whatever it is, okay? So once you have defined that, this is a jar file. Now in your actual index.x.html page, you can refer to the contracts that are defined in your jar file, which is bundled as part of your webinif lib. Take it a notch higher. You can drop this jar file, which has all the contracts, in your server common lib file or server common lib directory. Once you drop it in there, you can still, because the class resolution, the way it works, it will resolve it and can give you the right contract. So you can really share it across all the different applications deployed on a particular app server. JSF also added support for HTML5 friendly markup. Now here I'm saying h:\input text, and I'm specifying a type equals email attribute over there. Now type equals email is a valid attribute for HTML5, but the way JSF works, it has a corresponding UI component at the backing bean, and then it has a HTML render kit, which says, okay, hey, this is the UI component, and this is the corresponding HTML element or HTML code that needs to be generated with that. So effectively, it will say, hey, what, I don't understand type equals email. I'm just going to ignore it. I'm just going to say this is input text. Just put type equals text over there. So that's an issue because that's what your intention is for HTML5 page. Now with JSF 2.2, you can say, I'm going to put this element in a pass-through namespace. So here I'm saying p:. It's a random prefix chosen, but it could bound to the pass-through namespace that is defined by the spec. So you could say this is in a pass-through namespace, in which case the actual attribute that is generated for you on the runtime or in the HTML page is type equals email. So that's the benefit. Now your user agent, which is your Chrome browser or your mobile browser, whatever it is, it will render the element correctly because it's type equals email or type equals color, for example. Now if you click on that element, it will automatically bring your operating system specific color palette. Finally, JSF also has a file upload component. It's tied to the multi-part support that is added in Servlet 3.1. All right, let's kind of start on the right side of the pancake here. So we have a new API to consume REST services. Jax-Rs, the focus has been primarily on the server side. Take a POJO, put an annotation on it, and publish it as a REST endpoint. Now we have a brand new client API. So you can say, from the client builder, I'm going to build a new client. I'm going to set the target, which is the endpoint that I want to invoke. Then I can build a generic invocation object, and then I can invoke it, and they'll give me a response. So you can do a little bit more detailed way, or you can say, I don't care about all that detail, just use the builder API. So you can say, build a new client, set up the target, give me the request, this is the text plain media type that I care about, and get me the response back. So this is the on-the-wire media format. Or you can say, I don't care about on-the-wire media format, just build the same request, set the target, and give me the string response back. So it can get very fancy very quickly. Jax-Rs also added support for async client and server. In terms of client, what we have is, you could just say .async over here, and then that becomes automatically async. So what you get here is a future object, standard JDK object. So you get a future object, and then on future you can say get, or basically cancel the request, whatever design patterns are there on the future. On the server side, there is an async server as well added. This API is not very clean in my opinion, and it needs some work. But the current design pattern is, if you have a method in your REST endpoint, you say add suspended. So as soon as you enter the method, this method is suspended and delegated to another thread. Now here, I'm using new thread, not a right design pattern. It should really be using manage executor and delegating it to that manage executor to spin up a new thread. But that's sort of the idea. Jax-Rs also added support for filters, which is targeting towards parsing your HTTP headers or addressing your cross-cutting concerns with only the headers. So here in this case, I have, well, think about this. There's a client and a server. There's a request on the client, response on the client. Similarly, request on the server and response on the server. So client request response, server request response. There are 4 interception points. And that's what the interfaces look like. So you have filters on the client side and the server side. And the way you run them is, or the way you implement them is, I want to build a logging filter, and in the logging filter, I just want to kind of track or list all the HTTP headers, for example. So I implement request filter, and then it gives me some information about the HTTP headers over there. Then we also have Jax-Rs entity interceptors. These are called on the actual message body. Now remember, if you are using entity interceptors, the entity needs to be bound. And if the entity needs to be bound, it may invoke some of your business processing logic, like either talking to a database or invoking some other service. So that's why the split is important. Filters towards headers, interceptors towards the body. A typical use case for entity interceptors is you want to gzip the body, for example, or ungzip it. So you could look at the filters, HTTP headers, and then based upon that make a decision whether you want an interceptor or not. And that decision could be made dynamically. JSON-P, JSR 353, it adds the support for a low-level JSON processing in the Java EE 7 platform. So for example, here I'm saying create an object builder, add some name value pairs, add a named object over here, and add some name value pairs over there, and you build the JSON object. So simple API, but very low level. It's not like taking a Pojo, putting an annotation on it, and be done with it. Hopefully that will be part of Java EE 8. So that was the generation part of it. It can also parse existing JSON structure. So you can say, I'm going to read from a file reader. Order.json has some elements in there. And then when you're reading the element, give me events. Events like start of an array, start of an object, end of an element, or a value. So give me those objects. I'm interested in a particular key, for example, and I'm going to compare the key. If I'm interested in the key, then I will read the value. Otherwise, I'll keep ignoring the elements. So it's a lot faster way of processing your JSON. Batch. Batch is a new addition, JSR 352 to the Java EE 7 platform. Most of this work actually came from Spring or Pivotal. They keep changing the name all the time. But the thought process is a batch job has a step. And within a step, for example, and we're looking at item-oriented processing. In an item-oriented processing, what you do is you read an item, you then process an item. Process could be validation, for example. Think about a CSV file that you receive at the end of the day, and you want to read each line and validate it. If it's valid, then you want to write it to the database. For each read, you may not want to write. That could be a costly operation. So what you do is you read an item, you process an item. You read and you process again, and once you have aggregated a bunch of items, then you can say, I'm going to go write it, and that's when the write item comes. So this is called as one chunk in terms of batch. And your chunk effectively is defined in your job XML or job specification language. So here I'm saying chunk. I'm defining how many items in a chunk. So I'm going to aggregate 3 items here: reader, processor, and writer. And I have references to the corresponding CDI bean that does the real job. So how does this bean look like? Well, I have implementing item reader, and then I have a read item method that I override, and I say read the account using JPA. This could be reading a simple line from a CSV file. Then there is a processor. So whatever item is being read over here is returned to me in my process items method. So this is plain reading. This is plain validation, or it could be a conversion. For example, you may be reading a string and then here generating a JP entity, and that is perfectly valid. And then finally, everything that you have just read or validated is already available in the list, and then you can just write it out. So we saw the item-oriented processing. We also have ad hoc processing, where you can just do one job ad hoc. It's like send an email or upload a file. That's called as batchlet processing. There are listeners available at job, at step, at reader, at processor, at writer, all different levels. So you can do before and after a particular step is being executed. And this is the job XML, that's how it looks like. There are interfaces and abstract classes depending upon what you want to use. So there are convenience classes over there for you. For example, here I'm saying my job listener extends abstract job listener. This is what I want to do before job. This is what I want to do after job. So you can put in your methods, initializing resources, whatever. You can declaratively split up a job so that it can run on multiple cores, for example. So here I have a chunk, a step has a chunk, which is a reader. Let's say I have thousands of records. So let's say 1 million records. And I want to split up reading of those 1 million records across 4 core machines that I have. So 250,000 to each. So here you can say, I'm going to specify the start and end property. And the way those start and end properties are specified are further in my job XML. I can say partitions is 2, partition 0, start is this, end is this. Partition 1, start is this, end is this. So you can do that declaratively. This is one way of doing it, by which you can declaratively say, split up my job into 4 partitions. And I'll get back to you in a programmatic in a second. But another concept in batch is how you can say, I want to execute certain elements as a unit. So I can define a flow, and in the flow I could say, step 1, step 2, step 3, and do this as a unit. And then after flow 1 is completed, then do flow 2. So you can start building your workflows over there. And here I'm saying, this is my ID flow 1. Once you are done with flow 1, the next step is step 3. I can run the flows concurrently. So all I'm saying here is, these are my 2 flows. I can just say split, and this is going to run the flows concurrently. And this is about creating workflows programmatically. So like, let's say at the programmatic version only, you can find out what my server configuration is going to look like. So you can start splitting up your load accordingly. Here in this case, what I'm saying is, I got all the step executions that are happening for me. Then at a particular case, if the job is not doing the required performance or the required job, then I return data loaded, a particular data status or a job status. And in my job XML, I could say, if the job status is data loaded, you just jump on to step 2. Or if it's not loaded, then you end the job. So pretty comprehensive workflows can be created using job XML or programmatic jobs. Javamail, a simple addition, bunch of minor improvements, but the simplest addition that was made to the API itself was how the mail session definition can be easily created at the deployment type itself. So no longer a script is needed for, create this mail session definition, by the way. Same thing with JCA. So your connection and object definitions can be created from deployment. So you can just specify the annotation on your JCA connector. Broader on the platform level, some things were added. So for example, a default Jindy data source was added. If you're building a Java E7 application, most likely you need a database with a backing for storing all of your information. So if you need a database, you might as well provide a default data source. So the idea is, you can just say add resource data source, and it's going to give you the backing data source. Or you can explicitly specify the default JNDI data source as well. We talked about default JMS connection factory, all the standard ways. There's a default managed objects as well for JSR 236. This talk was originally given by myself and Antonio at Java 1 last year. We both have written books. So the 50th tip is, if you want to learn more about Java E7, buy our books. They're not that expensive. last but not the least, I want to leave you with some pointers. So this, for example, this is a GitHub repo where there are about 200 samples on Java EE 7. These are not just samples, but these are also your Orchelian tests that run on Glassfish and Wildfly on both the application servers. So we would love to see pull requests. We would love to see issues that, Arun, this particular sample is missing. There are about 32 contributors to these Java EE 7 samples. We did a hackathon at last year, DevOps Belgium, where there were a bunch of people who contributed lots of tests. So I'm looking for contributions, pull requests, issues, try them out, tell us what is missing, tell us what can be improved. And then, if you guys did not participate in the hands-on lab that was done 2 days back over here in DevOps France, this is an end-to-end hands-on lab which gives you a complete design pattern exercise for Java EE 7. It's about a 70-page document, walks you through on how you can build a Java EE 7 application using NetBeans and Glassfish or Wildfly, either of those application servers. So both the options are available. And once again, we're looking for pull requests for that. And this is a word from my sponsor. Wildfly is the latest Java EE 7 compliant application server. And that's about it. I'm going to post the slides. Well, I already posted the slides on SlideShare. So at the next moment, I'll share the link on DevOps France hashtag. Feel free to retweet, share it. Would love your feedback. Thank you.